Good evening. I'm hoping you're all keeping well, especially if anyone here is in a state of lockdown. I know that's really tough. I hope you get through it as easily as you can. I wanted to start by acknowledging that I am currently on land known as both Birrarunga and Narm, and it's stolen land that was never ceded. I pay my respects to elders past and present of the Wurundjeri and Boonwurrung peoples of the Eastern Kulin Nation, and thank them for their ongoing care of people, land, and culture. So, if there's anyone here on this call who I've not yet had the pleasure of meeting, my name is Pat Allen. Much like a few people on this call, including David, who just spoke, I have been using Ruby for a long time, but I still love it. And tonight, I'm going to talk about something that you will almost never need to do within Ruby, but I was kind of happy to learn that it was possible, and that is resolving DNS lookups. And now, oh, there we go. It did change slides. So if you've got no idea what DNS is, domain name system, domain name servers, that's okay. I'm going to provide a very rough, simplified explanation. And anyone who does have a good idea of what it is, as I said, this is a very simplified, rough explanation. I don't need corrections. I know it's not perfect. Just grin and bear it, please. So every app, every website is on a server somewhere, and a server is really just a computer. And when those servers connect to the internet, they are given an address, an IP address, an internet protocol address. But these addresses aren't really made for humans because they're a little hard to remember. I've got some made up examples on the screen here. This is the version 4 of IP addresses. You'll see there's 4 separate numbers. They can be anywhere from 0 to 255, separated with colons. Now, if you wanted to go to IP version 6, you can see that they're even harder to remember. This is why we don't use them as humans. And I'm going to stick to version 4 on the screen just so there's room for other things on my slides. Yeah, we don't use them. We use domain names because they're much easier to remember. But we need a way to know which domain name goes with which IP address. And that's what DNS does. Think of it like an address book, or once upon a time, the Yellow Pages. You don't need to know everyone's phone numbers off the top of your head, but if you know their name, then you can find their phone number. And it's much the same kind of deal here. So when you type a domain into your browser, your computer asks a DNS server, which is usually supplied by your ISP, which IP address should it actually be talking to? And if it doesn't know, it will ask another DNS server. And if that doesn't know, it'll ask another DNS server. There's a hierarchy. And eventually, once the detail is found, it's passed back and you're told which server you should actually talk to. But much like how people can move homes or change phone numbers, domains can change IP addresses. So the DNS system tries to keep track of these changes, but also because it doesn't want to figure out a DNS resolution every single time you're asked, because that could be quite a lot of times and it could make things quite slow. So DNS servers have a short-term memory where they remember common domains that they've had requested in the last little while. And that makes DNS resolutions much faster, which is fantastic. But it means it takes a while for these servers to catch up on actual changes. Depending on how you've got it set up, it could be even a day or two until the whole internet is aware that actually this domain goes over there. Okay, that was a bit of an information dump. I hope it makes some kind of sense. And just to be clear, I'm not looking for corrections, but does anyone have any questions about that before I dive into the next bit? No? Okay. I'm hoping it all made sense then. So normally when a computer wants to know what the actual address for a domain name is, it asks the DNS server. Well, that's kind of correct. There's actually a step or two in between, because your browser may have its own cache, and so it doesn't need to always ask if it's already had that domain name requested recently. And your operating system has its own cache as well. So these, remember, so that the query kind of makes its way through. And if you're writing Ruby code, then Ruby kind of has a step in itself to figure out what the DNS resolution is. And it turns out you can do that yourself in Ruby. So here's a little example. I'm looking up what is the IP address for ruby.org.au. And it turns out there's actually 4. If you run this code on your machine right now, you should get probably that same result, unless there's been a change in the past 24 hours, maybe. And in this case, there's 4 because ruby.org.au is hosted on Heroku, and they have many servers, and these are the ones that can respond. So yeah, in Ruby, that's how you can make DNS queries, which is awesome. Wow. But that was a lot of talking for not very much code. And actually, it's not quite the code I was looking for, because I wanted to interrupt a DNS request. I wanted to say, look, I know you're looking out there, but I've got a better answer right here. And it turns out that's also very easy to do as well. So you can create a custom resolver, and all that needs to do is respond to the each address method that I was using in the previous example. And that each address is given a domain, and if it knows the IP address for that domain, it should yield it. It can potentially yield, as we saw, more than one result. So once you've run this code within your Ruby script or your Rails app or whatever, everything after that point is going to use this to figure out any DNS resolution. And that's kind of cool. But in this example, it's gonna do it for every single domain, which is not so great, particularly in the example, because that'll just talk to your own machine. And we don't want to manage, or I presume that no one wants to manage every single domain to IP mapping. That would be a lot. So what would be better is if we can specify these are the specific domains that we want to resolve, and we're not going to worry about the rest. So we've got our custom resolver that takes in a known set of resolutions, it yields them if it matches, and otherwise it does nothing. And that works. That's great. We ask for that domain, we get our custom IP address back. Fantastic. But if you then request any other domain, it's going to fail. Apparently google.com doesn't exist anymore. If anyone wants to get in on that, I'm sure it'd make a fortune. But thankfully, Ruby gives us a way around this as well. So you can stack resolvers. If the first one doesn't yield any results, the request is passed on to the next one in the chain, and so on. And so instead, we can do this. We can use our custom resolver for things that we care about, and then otherwise fall back to the default, which means that Google now works again, which is wonderful. And that's pretty much the core of what I wanted to talk about, just the way that you can actually do this. 2 final notes, and then I'll leave you to enjoy your evenings. firstly, if you do want to give this a shot, since version 3 of Ruby, the Resolve libraries that I've been requiring are now separate gems. They were part of the standard library, shipped with every release of Ruby prior to version 3. So if you're writing code in Ruby 3, make sure you have the gems there, and either way, you'll still need to require them. And the second point is Yagni, which, if you're not familiar with that, you ain't gonna need it, except if you do. Because mucking around with DNS is really not a common activity. But I did have one situation recently where I did need this. I wanted to use SSL to talk to some internal servers of mine, but SSL requires a domain name rather than an IP address. And these internal servers have IP addresses that can change quite frequently. So that means I can't rely on standard DNS resolution because it could be out of date. And then I can't talk to my servers until the rest of the internet catches up, and that was a problem. So what I've done is I've given each server a subdomain, and I track which IP address belongs to which subdomain, and then I use my custom resolver only for those subdomains. Everything else, it doesn't yield, and the request goes on to the standard resolver. Now, I'm pretty sure this is the only time in over 15 years of working with Ruby that I've ever needed to do this. And maybe I'll never have a good reason to again, but it's neat. Anyway, that is all really that I had to say. I hope you've learnt a little, and I very much hope you use this new knowledge responsibly. Did anyone have any questions? I've stunned you all. You're shocked that such a thing could be done.
Thanks, Pat. That was pretty cool. Yeah, pretty interesting.
All right, I think we're done. I'll stop sharing the screen.